Consider this grayscale image. Now this image is made of pixels. This particular one has 3 by 5, so it has 15 pixels. So it's quite a small image. Now each pixel has a value, and that's what defines the intensity of the gray color for each pixel. So in reality these are numbers, but our computer display shows them in a color format, which is easy readable by us humans. Where I'm trying to get is that programs use numbers to store images. Then the computer display, or so the screen, converts these numbers to colors. Python can also do image processing, just like Photoshop does. Probably it cannot do all the cool stuff that you can do with Photoshop, but you can make use of Python to automate things. For instance, we'll be using the image processing capabilities of Python to detect faces from photos, from images, and also detect moving objects in videos as well. So videos are made of images, so it's the same thing basically. And Python stores and reads images using arrays of numbers. For instance, this image could be represented as, a list of 3 other lists. So 3 lists because we have 3 rows there with pixels, and then in each of the lists you'd have like 5 numbers, and so on and so on, and the 5th, and the same for the other 2 lists. We've got 5 numbers because we have 5 columns, so 5 pixels for each row, and that's an image for Python. And here is where Numpy comes in handy. So while you can represent images with lists as we did here, this is not very efficient because for big images, lists occupy lots of memory and therefore they slow down operations on them. So this is solved by Numpy, which is a Python library that provides a multi-dimensional array object. So let me go ahead and create this array object. First of all, what you need to do is you need to import Numpy, and if you have installed pandas, Numpy should have been installed with pandas because pandas is based on Numpy. If you haven't installed Numpy just yet, just go ahead and pip install Numpy. And if for some reason you have some problems on Windows, then just go ahead, as I've showed you, and find the precompiled Python libraries. Go to this side and then search for Numpy. And then figure out if you're on a 3.5 version of Python, then just get that version. And then you point to this file with pip install and the name of the file. Great. Now I have Numpy installed, so I'll create this multi-dimensional object and store it in the n variable. And that would be numpy.arange, and let's say 27. Execute that and print out n. So this is a Numpy array. That's how it is called. This particular one is not exactly a multi-dimensional array because it only has 1 dimension. So it's like a plain list, a Python list, but still it's not exactly a list type. Sorry. So it's a Numpy n-dimensional array. It can have 1 dimensional, 2 or 3. So we have 1, 2, 3, and I'll show all these scenarios. So that was the 1-dimensional array, and if you want to print it in a nice form, and that would be the array. Now I'm just creating a Numpy array using numbers on the fly here, but normally you'd have to create arrays from images, and we'll do that in just a bit. So for now, let's create some arrays manually. Now let's see what a 2-dimensional array is. Shape 3 by 9. So we already have this 1-dimensional array, and we want to convert it to a 2-dimensional array. If you execute that, you get a 2-dimensional array. So that's a 2-dimensional array because it has 2 dimensions. So think of it as this image file, we have two dimensions, vertical and horizontal. Now, what's a three-dimensional array? Even though three-dimensional arrays are less frequently used, it's still good to know about them. And yeah, let me create a three-dimensional array. I could say 3 by 3 by 3, because you know you have 27 elements, so 3 by 3 by 3 gives you 27. And yep, that's a three-dimensional array. Think of that as a cube that has 3 dimensions, so 3 by 3 by 3. And practically you'll see that in just a bit in this lecture. Where do we deal with three-dimensional array? So bear with me. And yeah, you're able to see the similarities between a Numpy array and a plain Python list of lists. So this here would be like a two-dimensional array, if you like to call it like that. Yet the structure in the low level is different between Python lists and Numpy arrays. And also Numpy arrays allow you to make some more efficient operations such as iteration between the array items and so on. And you can also create Numpy array out of Python lists. For instance, I'll get this list here and I'll create a new object and then point to Numpy. And to convert a list to a Numpy array, you'd want to use as array method. And then between the brackets goes the object that you want to convert. And that's an array, which is almost exactly like this one in here. And if you print that, you wouldn't be able to see the difference. You know, they look exactly the same. But they are not, because this is a list and this is a Numpy array. Great, let's move on. So that's Numpy, and as I mentioned earlier, Numpy is a base library for other libraries such as pandas, and also OpenCV, which is an image processing library. So pandas data frames are based on Numpy arrays, and OpenCV objects are based on Numpy arrays. So what pandas does is it just adds some cool features in there, such as it gives capabilities for having table headers and indexes, which you can't have in Numpy, because Numpy is meant to be a more simple and in a more low level of storing objects and doing operations. And so Numpy is a requirement for many libraries. And yeah, let's stop this lecture in here, and in the next lecture we'll go straight ahead and create a Numpy array out of our image in here. So this image. Okay, see you there. And yeah, CV2 is installed. And now what I can do with CV2, among many other things, what I can do, the very first thing, is to load an image in Python using CV2 methods. So I'll be loading that image, which is a very small image, by the way. It only has 15 pixels. You know, a normal image that you use to take pictures or on your phone or whatever, it has like 1000 by 1000 pixels, which is 1 million pixels, more or less. But we should keep things simple so you understand what is going on. CV to import that. And yeah, that was successful. And now I'll create a variable and call this IM for image and G for gray. You can call it whatever you want. And CV to read an image, to load it in Python, you want to use image read method. And then you pass the name of your image. You can find this image in the resource section, so just go ahead and download it. And now this is here in the same directory with my Jupyter notebook, so I can go ahead and point to the name of the file, including the extension smallgray.png. And here the image read method also expects one other argument from you, and that can be either 0 or 1. So 0 means you want to read the image in grayscale. And if you pass 1, you're reading the image in BGR, which means blue, green and red. And you'll understand what each of the versions mean. So let's do this one first. And yeah, I'll print that. And yeah, that was it. So what we got is a Numpy array. It's a two-dimensional array. So it has dimensions 3 by 5, which is the same as our image. 3 rows and 5 columns. Now the reason we pass 0 there, so we're reading that as a grayscale image, is because you know this PNG file, in reality it has 3 bands, or you can say 3 layers, and each layer has a certain amount of colors. So for the first layer has a certain amount of blue, and the second layer has a certain amount of green, and the last layer has a certain amount of red. So combining each pixel is a combination of the intensity of blue, green and red. I know in other programs they use RGB, in OpenCV uses BGR. Now practically this file here, this image, practically is a grayscale image. However, each of these pixels has its own bands, so the combination of them always creates, in this case, these gray, white and black colors. But if we had a color image there, this would convert it to a grayscale, this function. So again, what we have here is, 187 is the value, the intensity for this first pixel. And then you have the other number, and for white, you see white here, we have 3 white pixels. And those are 255, all of them. And yeah, colors range from 0 would be black, pitch black, and 255 for white. And everything between them is in the grayscale. So now if I change this to 1, I'll get a 3-dimensional array, where this represents the blue layer, the green and the red. Or you can even print that out. Be careful though that this is a bit transposed, so the matrices are 3 columns in here and the rows are vertical. And basically what this says is this pixel has these corresponding values. So it has an intensity of 187 for blue, 198 for green and 209 for red. And yeah, that's how you create Numpy arrays out of images. But how about the other way around, so creating images out of an Numpy array? Well, to do that you'd use CV2 again, CV2, and then you'd point to the imWrite method, so image_write, and then you want to pass a name for your image, let's say new small gray.png, and then of course you need to pass your Numpy array. So let's pass image gray. Execute that, you get true, which means that your file should have been created now. Yeah, new small gray, and yeah, that's the file. And I hope that strengthened your knowledge about Numpy. Now we'll go ahead and do some more things here. Specifically in the next lecture we'll learn how to do indexing and slicing and iterating of Numpy arrays. So basically you'll learn how to access these values. See you there in the next lecture. Alright, you know how to slice lists. So 0 to 1 will give you the first item of the list, and 0 to 2, the first and the second item of the list, and so on. With Numpy arrays, you do basically the same thing, except with Numpy arrays, sometimes you have 2 or more dimensionals, or 3. So let me go ahead and I'll start with a 2-dimensional array. So I'll get that from this variable. So this is the Numpy array that we'll be working with. And yeah, if you want to extract this number here, this one, and this, so these 4 numbers, well, you'd first need to set the index of the rows that you want to slice. So that would be 0 to 2, which gives you the first 2 rows. Actually, we can try that. and you'll see that you get the first 2 rows. Now if you want only this portion here, so these 2 numbers and these 2, you'd want to pass a comma there, and then the index for the columns, which would be, 0 here, 1, so 2, 3, and yeah, 2 to 4 maybe, yeah, that should do it. And that's it. And that means you have this indexing system. So it starts from 0 for rows, and then the second row is 1 and 2 and so on. For columns, the same thing, 0, 1, 2, 3 and 4. And actually, if you like, you can see the shape of your Numpy array. So it's 3 by 5, which means 0 to 2 and 0 to 4. Great. And of course, you can use the convention of list indexing, so you can pass 0 and everything after that, or just like that. So you get all the rows and only columns from 2 to 3. Similarly, you can get only one value if you like. Not particularly this one, because 3 is out of the bounds for axis 0. So axis 0 is a horizontal axis, which says that there is no row with index 3. So we set is 0, 1, 2. So let's pass 2 there, and you get 182, which is the very last item of the Numpy array. And yeah, that's about indexing. How about iterating through a Numpy array? Well, there are 2 ways to do that. The first way is to say, let's say for I in your Numpy array, print I. What that will do is it will print out the rows of your Numpy arrays. So what this I accesses in your Numpy array is the rows. So in each iteration it gets the first row and it prints it out in the first iteration, then the second one, and then the third one. And if you want to iterate through columns, you'd want to access the transposed version of your Numpy array. And that's how you do it. And lastly, if you want to iterate value by value, you'd say for I in image and dot flat print I. So this property, what it does is it allows you to access values of your Numpy array one by one. And that's about indexing, slicing and iterating. I'll see you in the next lecture. Alright, now that you know how to do slicing and iterating through Numpy arrays, let's do some more specific operations. That would be stocking Numpy arrays, so concatenating Numpy arrays to each other, and also splitting a Numpy array to smaller arrays. Yeah, I have this Numpy array still here, so let's start with stocking 2 Numpy arrays. To do that, you may want to create a new variable where you'll save your big array, and that would be equal to numpy, and the method to stock 2 Numpy arrays. Actually, there are 2 methods. One is horizontal stack, so h stack. That expects from you to pass 2 or more Numpy arrays that you want to stack horizontally. So let me pass img and then the same array. It's not a problem. If you had 2 different arrays, you could do that, but I'm just passing the same array there. Now if you execute this, you'll get an error, and I want you to see this error so that you understand it. So it says hstack takes 1 positional argument, but 2 were given, which means that hstack inside the brackets it gets only 1 argument, but we're passing 2. So how do we go about concatenating 2 Numpy arrays? We can't just pass 1 Numpy array there. So the solution here is to have a tuple of Numpy arrays. Just like that. So a tuple inside the input of the hstack method. You execute that, and here is a stacked array. Yeah, so this is the first array, and then the next array, which in this case happens to be the same one, but if you want, you can add more. And you get a longer array, which is not very good looking like that. So you can print it out. And yeah, now you see the difference. So the first array, the second, and the third one. And if you want to stack vertically, you'd want to do V there. And yeah, as you expected, this will concatenate the arrays in the vertical position, in the vertical axis. Be aware that if you try to concatenate arrays that have different dimensions, you'll get an error. So IMC has 3 dimensions, if you can remember that from up here. Now you'll learn how to concatenate and how about splitting an array into smaller arrays. Well, to do that, you could create a variable and then numpy dot horizontal split for splitting horizontally, and then this expects a numpy array and how many arrays you want to produce out of that. So horizontally, let's say 3. And yeah, this says array split does not result in an equal division. The reason to that is, this array has 1, 2, 3, 4, 5 columns. So you're trying to divide 5 by 3, and NumPy cannot decide how to do that. So should it give to you a NumPy array with these 2 columns first, and then another NumPy array with 2 columns, and then a last NumPy array with 1 column? So NumPy cannot do that. Yeah, what you should do is maybe 5 there and LST, and that should give you 5 different NumPy arrays, which in this case happens to be 1 array for each column. And you can do vertical splitting. This time we can try 3 because we have 9 rows there. And yeah, we get 3 small arrays. Note that this LST, so the split, what it produces is a Python list of NumPy arrays. So it's a plain Python list. And out of that you can access each of the NumPy arrays if you like. You know that. So it outputs the first array. And yeah, that's about concatenating and splitting NumPy arrays. Hope I gave you a good overview of NumPy. I tried to do some practical examples like opening images, but this is still yet in the theoretical part, so NumPy is quite theoretical, and you only understand it when you get to use like these real-world examples like working with pandas as we did previously in the course, and also working with images. So we're going to do some hardcore image processing in the next lectures, in the next section. And you'll see how NumPy comes in handy in there. And yeah, I hope you enjoyed this, and I'll see you later.